we're going to go ahead and complete our tables from start to finish. And as a reminder, we're going to do this from start to finish so that way you have a little bit of a refresher. If you would like to jump ahead, feel free to fast forward a little bit to the bivariate tables where I'm going to give you some explanations on those as well. For the sake of today, I will not be going through columns B and C. I will remind you how to do that, but I won't be doing that so that way we have enough time and focus on getting done what we need to get done. So don't forget your formulas, right? So the sum of your frequency times your y divided by your n and everything that goes with that. With our percentage distributions, as a reminder, you can just go equals. You're going to click on that particular frequency and divide it by your total, and that's going to give you what you need. Now, you can always, mine defaults automatically, but in order to do that with all of your percentages, you will highlight what you want to have converted over to percentages, go to data. Sorry, just kidding. Go to format, number, and it'll be either on number or automatic. Go to percent right here. And you can do that for all of your columns where you're trying to calculate a percentage. So we're going to do this, right? I'm pressing equals. I'm clicking on the frequency and dividing by the total. And that gives me a amount. You can always sum it so that way you know that you hit the 100%. I'm going to go ahead and do that for all of them. You'll notice that it becomes pretty intuitive. You need to double check to make sure because some folks have learned that it will actually have a much higher percentage because it's clicking on different cells. So just make sure you're paying close attention to that as you're going through. So equals sum, right? And I'm clicking on the cells that I need. So this is going to obviously be 0, but just so we can get into the habit of it. Oops. Okay. Right, we're trying to do this so we can go through, have the totals. And I'm going to press equals sum, open my parentheses, click on my top cell. I'm holding shift down and clicking on the bottom. And that gives me that. Okay. So I'm going to go through and finish each of the tables myself. So in this case, because it's ordinal, remember that you are assigning it a y value, right? Remember that this is a y, this is the number value or the y value that you're assigning it because these are ordinal. There is an order. You need to keep them in their actual order for the number value to have some sort of meaning. So in this case, I'm going into this column. I'm going to press equals because it's f times y, right? Remember, you have everything labeled f times y. I'm multiplying this f times this y. So I'm going to press on that cell, shift 8 for the asterisk, and I'm going to click on that. And I'm going to go through. Again, it becomes intuitive. You'll need to do a double check. So 4 times 2 is, in fact, 8. 2 times 3 is 6. Okay, I think it's pretty safe to say that that's right. Now, in order to get my mean category, what I need to do is I do need to add these all up. So you'll see I'm just going to click equals sum, open up my parentheses. All right. Now the formula, as you should remember, is the sum of f times y divided by n. So in this case, then your n, right, is your total frequency. So with that, my f times y, my sum of f times y is literally these all added together, which is where I got that. So in this case, my mean is going to be this value divided by my total frequency, which gives me 2.4. Again, with ordinal values, remember that doesn't mean anything unless we have considered the numeric value or y value. When rounding, it's most closely related to this one here because 2.4 rounded down, which means that sophomore is really my mean, right? So sophomore is my mean. And in this case, I would say 2.4 sophomore. Oops, sorry, no equal sign. There we go. Okay. Next, I'm going to look at this. I'm going to say, okay, well, the highest percentage is sophomore, which means that it has the highest frequency, which that gives me sophomore for my mode. Because remember that your mode is reported on the category. All right. Well, now if we think about the formula for our standard deviation, right? Our standard deviation formula should be remembered for calculation purposes, in which case it's the sum of your y minus your mean squared over n minus 1, and then you take the square root of that. All right, so that's our formula, right? It's the sum of your y minus your mean squared divided by your n minus 1. So in this case, my y value, because 2, I'm just going to block this out. I'm going to highlight this. And I'm going to block this out just so that way I have it. It's easier to work with here. Y minus my mean. So my y value is 1 minus my mean, which is 2.4. I'm going to go through and do that. My y value minus my mean. Okay. Now I have to square each of those, right? So this is negative 1.4, shift 6 for the little caret. That squares that. And shift 6 for the caret. Now I need to add them all up because it's the sum of y minus my mean squared, which then is 4.88. What I need to do now is I need to go ahead and run the calculations. You can do it directly in here, but I've been suggesting that most folks use Desmos scientific calculator. So we're going to go ahead and, excuse me, I'm going to run the calculation. You need to make sure that you square it because, or you square root it because that is one of the common things that tends to happen. So this is my sum of my y minus my mean squared is 4.88. 1, 2, 3, 4. So divided by 3. All right. So that gives me the standard deviation of 1.2. We'll say 8 because it's 75555, or sorry, 755. Okay, so that gives me a standard deviation. Remember that my z-score is y minus the mean divided by the standard deviation. So in this case, here's my column for y minus the mean divided by my standard deviation, and that's what gives me my z-scores. So y minus the mean divided by the standard deviation. If I'm going through it quick, it's because we've gone through a lot of this already, and I want to make sure that you have a refresher. Okay, now for our interval ratio, it's a very similar process, except we don't have to give it a y value. It already has one, right? So now what we're doing is we're going to go ahead and do the similar process, just a little differently. So we still do our f's times our y's. So in this case, 1 times 0, because 1 is the frequency and the y is this number over here, right? So 0, 1, 2, 3, 4, 5. So I'm going to go through and I'm going to multiply it by my interval ratio value. In this case, I'm going to go through and keep doing it for each of them. Okay, and I'm going to now add them all up. And that means that I'm going to still do the same thing that I did before, which is equals this divided by my n. Because this is interval ratio, this is going to basically be 2.60 classes. So the average number of, in this case, right, this ordinal is like the class standing of the people who took this survey for me. Interval ratio, this is the average number of classes that folks planned to take when they finished and graduated high school, what their initial plan was. So across all of the 10 people who were surveyed in this particular case, that means that the average number of classes that folks planned to take when they finished high school was 2.60 classes. All right, now what that means is I'm going to do my y minus my mean. So 0 minus 2.6, 1 minus 2.6, 2 minus 2.6, etc. Go through and do the same thing for all of it. Okay. Now, because I have those, what this is doing is, and I blocked this one out here because it's a little more complicated with our ordinal. And now we're going to square these values. So I pressed equals, I clicked on the cell, shift 6, square, doing the same thing for all of them. Again, even though it's intuitive, sometimes it can suggest the wrong cell. So notice that it's suggesting this one, and this is what I need. So again, I pressed equals. I clicked on the cell that I need, shift 6, 2, and did that for all of those. Okay. Again, because the formula is the sum of my y minus my mean squared, I'm pressing equals sum, opening my parentheses. I clicked on the first one, pressed shift, held down all the way to the bottom, and that gave me my sum. Now with that, I'm going to do my formula again, which is the square root of 17.56 divided by, in this particular case, my n minus 1 is actually 10 minus 1, which is 9. And that gives me a standard deviation now of 1.397. The reason that I did it this particular time is because we're doing the average number of classes. This was the average category. So yes, our n minus 1 now for standard deviation up here was this, but because we're working with the mean category, but down here, this is the mean number of classes. So this is why this ended up being 9, because 10 minus 1 is 9, and that's our n minus 1 for standard deviation. So this gives me a standard deviation of 1.4, and if we look at this, this ends up becoming, our mode is 4 classes. So mode is 4 classes. Z-scores are going to be the same thing, where we're doing equals our y minus our mean divided by our standard deviation. And we're going to go through and do that for the same thing across all of them, like we have with all of our other standard deviation, all of our other Z-score calculations. As I mentioned, I'm not going to go into the back of the book to find the column B's and C's. But remember that that is where this is Appendix B of the textbook. Okay, so that's how we went through our interval ratio. For nominal, we're not having to do any of these tables here, but what we do need to do is do our IQV. So in this case, remember, you cannot press the cell that is before it. You cannot press the cell before it because it'll square it as a decimal, and when you square decimals, they get smaller. So 0 squared is 0, equals 20 squared is 400, right? We're doing all this. If you notice, again, I'm pressing equals and I'm typing in the number, shift 6, 2. I'm doing that for each of these. Okay, and then we have to add them all up, because remember that the formula for IQV is the sum apologies, my bad. Sorry. The formula for it is there we go. The formula for it is, sorry, K for the number of categories times 100 squared minus the sum of percentages squared divided by 100 squared times K minus 1. where K is the number of categories. And for this nominal category or this nominal variable, you have to make sure that you keep the, even if, for instance, I have 0 for none or undecided, I have to keep there in there because this is measuring diversity. So this is going to measure the diversity of my nominal variable or the number of majors that they're choosing. So when I plug in this value, let's see, I have 1, 2, 3, 4, 5, 6, 7. So 7. The sum of percentages squared is right here, right? So that's because I squared all my percentages and I added them up. So that's the sum of percentages squared. And when I calculate this, this gives me an IQV of 0.887. So we'll say 0.89. Okay, so that gives me an IQV of 0.89. And then my mode, looking at this, the percentage, this is actually bimodal. So what I would say is bimodal, STEM, and arts. Okay. So this has given, I've been able to fill out all of these parts in my tables, and this has given me, the foundation of what we need from here for now. What we need to do now, though, is we need to transition into our actual bivariate tables. So the bivariate tables are where we're going to create a table that looks for a relationship between two categorical variables. And in this case, now I might want to look at the relationship between my ordinal and my nominal. So what I might be curious about is there a relationship between class standing and major? In this particular case, what I would likely say is that, I think that the class standing will impact major, right? And there could be a variety of reasons for that. It could be classes that you've taken. It could be, you've had an opportunity to explore more options. And that means that I'm going to convert that into a bivariate table. Now, some of this data comes from a previous survey that I had done. So if we're looking at this, this is from a different one where it was like, did you plan on attending college and whether or not they saw a counselor regularly? So this came from a survey that I had completed or that I had created and I administered. And this was basically whether or not they planned on attending or they were intending in some sort of program after school. And this was like the participants, right? And whether and what they said directly. Then this is also another 10 participants and what their exact class standing was and what their intended major or declared major was. So you'll see this is listed by each of the participants. For your data, right, you will probably have somewhere between 17, maybe 15 and like 25 respondents. So if this is what this data looks like, you're going to probably want to have something similar, which you can just extract directly from the Google form. And it's going to end up being turned into two different tables that look similar to this. So this first one here, what I did was I broke down and I basically put down, where do they have plans on furthering their education? Yes or no, right? Those were the options that they could select. And then did they see a counselor regularly? Yes or no. And this is what this would look like. So first what I did was I tallied it down. So I literally went through, okay, no, no. All right, so that would be one right here. Okay, yes, yes. Okay, so that would be one right here. So I went through and I tallied each of them and I put down the numbers that went across all of these. Then I converted them into percentages, right? So 3 divided by 3 is 100%, 0. And that's how I came up with this table here. This is what this table would look like. I would suggest that you do this first, this very first part, then you create this one here. But then I'm going to go through and show you another example over here of how that might look kind of step by step based off of the data that we have in this very first section here. So as I'm going through, what I would need to do is I need to actually tally each of them and look at them. So if I'm looking at this, right, I have over here which participant it is. So participants 1 through 10. This is a duplicate. All right, so participants 1 through 10, freshman STEM, etc. All right, so what I'm going to do is I'm going to look at, okay, freshman STEM. So I can see there's 1, 2, All right, there's 2 that are freshmen in STEM. So in this case, I'm going to put 2. I may not need to tally it. If you have more data, I would suggest that you start tallying it. You could just put like the letter L or the letter I for a tally. It's up to you. Okay, so I have this. What I would suggest is maybe develop some sort of system. I might want to highlight it when I've already calculated it. All right, so there's 2. Okay, well, there's 2 sophomores who are social sciences. So I'm going to put 2 here. All right, cool. So that helps with that. All right, sophomore, that's behavioral sciences. All right, so that's that. All right. Sophomore, that's arts. Okay, so that's there. Junior, that's arts. All right, that's there. Junior, that's STEM. That's there. All right, senior arts and senior humanities. So humanities and arts. So that means I have 0 here, 0 here, 0. This is just how it's helpful for organizing and kind of being able to visualize your data a little differently, or to see, where the zeros are and where all the other values are. All right. Remember that the totals are called marginals, and the cells are where these meet. So if I'm going to go through now, I'm going to calculate what the percentages are. I'm going to need to total things out first. So we know how to do our sums, opening this, right? And we're going to go through and do that. Make sure we have everything summed out. Okay. What we need to do now, actually already just convert everything over so we know that this is going to be equals 2 divided by 4. So we know that total is 4, which is 1% equals 1 divided by 4 and 1 divided by 4, right? So we know that this is going to be 2 divided by 2 because it's the total number, right? We know that this can be 1 divided by 2 and 1 divided by 2 because that was the total in the box. And we know that the total here is 2, so we know that this is 1 divided by 2 and 1 divided by 2. All right. Now you will want to convert it over into your percentages. So highlight everything, go to format and percent. So that gives you percentages now across all of your data. You can see if you really want to total it all up, it will give you, you want to have 100% across everything because you want your percentages to equal to 100. Okay. Looking at this table, right, the reality is that a bivariate table only gives us one kind of set of ideas on whether there's a relationship. The next would be a chi-square test, which is chapter 10, and that would be diving deeply into, the actual relationship. Looking at this table, though, we can see that there may be some sort of relationship across class standing and major, right? There's a lot of reasons that this could be. It could be that folks, go in wanting to be STEM majors and realizing that there's more opportunities and differences that are later on in their experiences. This does tell us that there is some sort of relationship, though, especially if we're looking at the differences across percentages, when we're comparing them across the columns. So this may not give us like any definitive ideas, as like we're not necessarily looking for causation either. We are looking for relationships, though. Regardless, this does tell us that there is, that there may be a relationship across class standing, specifically when you get to the higher levels and art majors, for instance, or perhaps the different kind of breakdowns of being a humanities major as a senior compared to some of the others. So one of the biggest things is you're looking across the columns for the percentage differences when you create these tables. And for your case study, this is what you're going to be doing, is you're going to be creating this type of thing, this type of table where you're going to have your independent variable and your dependent variable, and you'll have the different options that were available for your independent variable, the different options that were available for your dependent variable, and then you're going to basically be creating the percentages inside there based off of the individual responses.